Hello and thank you everyone for being here today in this session. Thank you Pixelcom for having us. It's always a pleasure to be here talking to developers. My name is Carlos. I'm a solutions architect for Amazon Web Services, and today's talk is about serverless architectures, an introduction to AWS Lambda. But first, a quick show of hands. Who is an AWS customer already? Okay, quite a few. And which of you guys have already tried AWS Lambda? That's 3. Okay. So my goal for today's session is that each and every one of you can have an AWS account before the end of the year and you have tried AWS Lambda. Let's aim for that. Good. Maybe we can set a little bit of context about the options we have now for compute. We have virtual machines, the good old virtual machines that we are all used to work with. And of course, in the virtual machine world, the virtual machine itself is the unit of scale. So if you need more capacity, you need more to handle more traffic, more requests, you just add more servers. As simple as that. It basically abstracts us from the hardware. Now there is a new trend around containers. So more in particular, Docker containers, where basically the application or the container itself is the unit of scale. So if you need more capacity, you just add more containers. It basically abstracts you from the operating system layer. Okay? But there is the next level of abstraction, which is the serverless compute. It basically abstracts you from the language runtime, and the unit of scale is the function itself. So if you need more capacity, if you need to handle more traffic, more requests, you just execute more functions. That's serverless compute. So in Amazon, we have different options based on your requirements. If you're looking for virtual machines, we have Amazon Elastic Cloud Compute or EC2. If you want to use containers, we have Amazon Elastic Cloud Compute container service. And if you are looking for running functions and serverless architectures in the cloud, you definitely are in the right session. So these are the questions that you should ask yourself. Do you want to handle or manage servers, configure networking, storage, handle the operating system? Then you should go for the virtual machine option. If you like containers, if you want to control the scaling based on your application, you definitely should be looking into ECS. But if you just want your code to be executed when it's needed, AWS Lambda is the service to look at. But first of all, let me just a couple of slides of why we build AWS Lambda. So if you are an IT professional and you've been here for some time, you have been asking yourself many questions where you have to handle servers. So how many servers do I need to run my application? What is the type of storage that I'm going to use for this particular database? How I'm going to harden my operating system? Those kinds of questions you have to ask yourself when running servers. If you want to take care of this kind of architecture, you always have to take care of patching of the operating system, handling the scaling or meeting your demands, and adding more capacity in an automated way. You have to take care of the fault tolerance, the availability, and things like that. So that's basically the reason why we built AWS Lambda. You as a developer don't have, it's a scarce resource. We know very much at Amazon that software developers' time is very, very scarce resource. So we really want developers to focus on what really differentiates their business. Lambda is basically an event-driven compute. So there is something that calls the Lambda function and executes your business logic, your code, and that only is available now in AWS for you to run these kind of architectures. Benefits of AWS Lambda. So first of all, you don't have to run any servers. You don't have to take care of load balancers. You don't have to take care of storage. Those questions are out of the table. You can just focus on your code that you're going to use in your Lambda functions. Second, it's very cost effective. You don't have idle resources. You don't have servers underutilized. Your Lambda functions are executed only when they are needed. And the third main benefit that we see is that we are using our own code, common languages that you're used to work with, and we are not inventing this very fancy new language that you can use with AWS Lambda. You're going to bring your own code and execute it in the service. How does it really work? So basically, right now we support 3 different languages. We will be adding more in the future: Node.js, Java, and Python. But what is very powerful around the service is that you can bring your own libraries, but you can also bring native ones. You can build your package and put it into AWS Lambda, so you can basically do whatever you want with your code. It is flexible in security and in use. You can execute your Lambda functions in an asynchronous way or a synchronous way. It's integrated with other AWS services. So if you're familiar with the platform, you know that we have more than 70 services right now you can interact with. The resource model is very powerful. You just have to set how much memory you want to dedicate for your Lambda to run. And we will scale the infrastructure, the CPU, networking, and everything proportionally for that memory reservation. You can work securely against your resources inside your VPC. In Amazon Web Services, this concept of virtual private cloud is your logic container of all your resources, where you have control over networking, access. You have full control like if it was your own data center. Of course, you can have very fine control of who can execute or what applications can execute your Lambda functions and under what circumstances. There are different ways to create your functions. You can use your own, I don't know, your own editor, whatever it fits for your use, but we give you other options. We have plugins for Eclipse. We have plugins for Visual Studio. We have a very nice, what you see is what you get editor in the console. And you can create your own functions in your own laptop, zip them, and send them to the service with your own libraries. So you'll have full flexibility over there. You have access to the temporary file system of the container. You have access to the sockets, processes, and everything as if it was running in your own computer. We have SDKs for Python and Node.js. And of course, monitoring is very important for us. So it's fully integrated with our monitoring service that is called CloudWatch, where you can see a number of executions, the time that your functions are taking to execute, the throttles that your functions are experiencing. And of course, very important to have in mind, it is a stateless solution. So if you need your functions to persist information, you can interact with any other storage service. You can interact with the database, with our simple storage service, with whatever you want. You have full control of what your functions do. Let's take a little bit a closer look to the components of a serverless application. So the first component is basically an event, something that happens somewhere. This can basically be an event in your own application. You can have your mobile application that sends a request to an AWS Lambda function. Or you can use another AWS resource to trigger that Lambda functions. So when there is a change in data, maybe a table, maybe a new object in your data store, you can execute a Lambda function as well. Then after that, the second component is the Lambda function itself. This is the core component of the serverless application. So you basically put your own code in your Lambda function, and that is going to be executed every time a new event comes to the service. And then after that, the third component would be anything else. This can be an AWS service. This can be your own application running somewhere else. This can be whatever you want, whatever endpoint. I mean, you will have full control of your functions and what your code does. So basically, you can connect with whatever you want. At this point, we have many different event sources in AWS. How many of you have ever heard of Alexa? Okay, that's cool. So you can have Alexa call your Lambda functions. So whenever, by the way, Alexa is our voice service. So it's basically a way for you to automate actions based on voice commands. So you can talk to the Alexa service and say, for example, execute my Lambda function X. And that is going to connect to your Lambda function and execute it. So it's very powerful for that. You can integrate with Amazon S3, our object store service. You can also integrate it with DynamoDB, our NoSQL database service, Kinesis, and we are working on adding more integrations of other AWS services. All right, let's take a look to some of the use cases that we are seeing with serverless applications. So we all know the typical multi-tier application diagram. In this particular case, we have a three-tier application. We have the presentation layer. This can be a mobile application. This could be a JavaScript in a web browser. This can be whatever you want. Then we have the logical tier that is running in a web server. And then after that, we have the data tier. This particular case, it's a database. So this, in the most common and typical world, translates to something like this. In Amazon Web Services, you would use this, all these services right here. For example, as an entry point to your application, you will use a DNS service like Route 53. Then all the traffic will go through our CDN service cloud platform. Static content will be served from S3. Dynamic content will go then to your web stack. It will go through load balancers. It will go then to your web servers, where you have to take care and configure the scaling out and scaling in of your capacity to handle spikes and growth. Then we will go to another load balancer that will connect to the application servers. And again, you got to take care of the scaling in and scaling out of the infrastructure. And then you can use our relational database service to persist the information, to query about run SQL commands as you would do in your own infrastructure. How would you do this in a serverless environment? So this is a typical, real-world voting application. It's a voting in real-time application. And well, basically, you have a third-party service that is handling the votings or the votes from the customers. And this third party is configured to basically send a request to API Gateway, which is our API service. This API Gateway is going to then trigger a Lambda function that is going to take that vote and is going to put the metadata into a table in a DynamoDB table. In DynamoDB, we have this functionality that allows you to execute Lambda functions when something happens in your table, when there is a change. So in this particular example, when there is a change in a DynamoDB table, then it's going to trigger another Lambda function that is going to be summing up all the votes from all the people that are sending votes to the third-party service. Then we have a JavaScript application running in a S3 bucket that is then published into my dashboard.com domain through Route 53. So users can query that JavaScript website and take a look at how the voting is going by querying to the DynamoDB table. You can do this with no servers, as you can see in the screen, and in a secure way. Another good example we're seeing in customers is real-time file processing. In this particular example, we have an integration with Amazon S3. Amazon S3, our object store, basically has an option to trigger Lambda functions when there is a change in a bucket. Bucket is a concept of maybe a directory. So in this particular example, you have a file coming into a S3 bucket that then is going to trigger an event that is going to be published to SNS, our simple notification service. This SNS topic is going to act as a funnel, and it's going to call 3 or n Lambda functions at the same time. This is very powerful because in this particular case, you can run some manipulation in this object that has come to Amazon S3. You can have another Lambda function that is running or summing up how much information is being processed. You can do whatever you want, having in mind that the event brings metadata about the S3 object that has been pushed to Amazon S3. We have a customer in Spain, I don't know if you know it, it's called Idealista. It's the biggest real estate or the real estate website that has more traffic in Spain, and they are doing all their image processing and video processing with this architecture in a serverless fashion. Another nice example is stream processing. We have another service for a fully managed service called Kinesis, which is basically a data ingestion service and analytics tool. So you can basically ingest whatever amount of information in real time and process it in real time with this service. In this particular example, we have an integration with Kinesis that can react and call a Lambda function when there is an event coming into the Kinesis stream. These two Lambda functions, one of them is aggregating all that information that is coming through the stream and putting it back into an S3 bucket. So that can be for archiving or for storage or for later processing with a Hadoop cluster. The other Lambda functions is storing information into a DynamoDB table that basically is going to serve as a dashboard so people can see in real time what's happening or what's coming into the stream. Okay? Of course, CloudWatch as a monitoring tool to see how your functions are working, if there are any errors, and you can also take a look at the logs. You will have full control of all the logs of your Lambda functions when they execute. Okay, in the serverless stack, a very nice component to use is Amazon API Gateway. So you can see here in the diagram how this service basically works. So you have different clients making requests to the service that is going to go through a CloudFront distribution. Remember CloudFront, our CDN service, and that is going to call the API Gateway service. You can enable an API Gateway cache where you can cache frequently requested requests to have a faster response. You will always also have monitoring with Amazon CloudWatch. And of course, Amazon API Gateway can proxy all those requests to Lambda functions or to other services running in a virtual server or other services running somewhere else in another provider. Okay, what are the main benefits of API Gateway? So first of all, it's like a unified API that you can use for all your microservices. Nowadays, everybody is talking about microservices architectures as well, so you can use API for those. You have protection by default. By using CloudFront as a CDN in front of API Gateway, you have protection for DDoS, and you have access to our web application firewall, where you can set up your own rules and update those rules via API in an automated fashion. So you can react very quickly, in less than a minute, all your rules are replicated in all our platform network. You can react very quickly to any kind of attack. Of course, very important, you don't want any of your clients to exhaust your backend resources. So you have throttling control over the requests that you are doing to your own backends. Of course, authentication and authentication requests. This is very important for us. So we want you to use API Gateway in a secure fashion. This is a nice example to use API Gateway as a unified front end. So in this example, you basically you can set up your own API Gateway in a particular resource to call an on-premise web server. In the meantime, you can do a migration, migrate your web server to AWS. And once the server is migrated, then you can change the API Gateway endpoint to call your new infrastructure in AWS. Very powerful for migration projects. DDoS protections. What do we mean about this? So basically, all your clients are going to go through the internet, through our points of presence in CloudFront. That is going to give you layer 7 and layer 3 protection against denial of service attacks. And of course, as I said, you will have throttling control of the requests that are going to your backends. So in this particular case, maybe you don't want your partner services to have unlimited access to the number of the requests they can do against your databases, for example. Authorization. So we support SIG version 4 in API Gateway, and we take care of calling all the rest of the services that you are using as a backend in a secure way once you use HTTPS with the service. So all communication is encrypted and is secured. At the same time, we have a very nice blog post that explains very in detail how you can use custom authorizers to authenticate your users or your request against an auth provider. So if you guys want to know more about this, please find me later. I can give you the link. Let's take a look about around the serverless stack. So this is basically it. A request comes from, for example, your mobile application, then goes through API Gateway, and that executes a Lambda function that you then persist information or interact with other service. In a closer look, what is happening is the request comes to CloudFront against one of our points of presence. API Gateway queries the cache. If the request is over there, then it's passed back to the client. If it's not, then it's going to query your Lambda functions or your EC2 service or your on-premises services. You have full control on how you configure your API methods. So we came up with this very nice serverless manifesto. So have in mind, serverless applications have functions at as the unit of scale. You don't have any machines, you don't have any containers in the programming model. Persistence is somewhere else. So you won't persist any information in your functions because that is going to go away. It scales per request, very important. You don't unprovision or over-provision capacity. You just execute the number of functions that you need when you need it. No pay for idle, no cold servers. That's very important as well. Bring your own code. That's also a very nice thing to have because you can execute your own code that you are familiar with now in your on-premises environment and put it into a Lambda function, and that's it. So the effort is very low to migrate to a serverless application. It's fault tolerant by default. Lambda functions, we don't care about fault tolerance. It's built in the service itself. And of course, metrics and logging is a right. So you need to have full visibility on how your functions are performing, access to the logs, and you have, in CloudWatch, you can even set your own alarms based on the filters that you create on the logs. A word on Amazon DynamoDB. So why is Amazon DynamoDB a good place for your serverless applications? DynamoDBs are NoSQL database service. Some of the benefits, it's fully managed. That means that you don't have to take care about any servers, any storage, any networking at all. You just gotta tell us how much capacity you want from the service. And you can change that capacity whenever you want via an API call. So it's very, very, very simple to scale out, scale in, and meet your demands. It's very fast and consistent performance. We will see later on a very nice graph representing this very nice benefit. Highly scalable. We are going to always provision enough capacity to meet whatever are your demands. So it doesn't matter if you have 1 request or 1 million requests per second. The service is going to deliver. That's very nice. It's very flexible to use. It's event-driven. For serverless applications, this is a must-have. So if you want to react on changes on data, this is a must-have, event-driven compute. So whenever something happens in your DynamoDB table, that is going to execute a Lambda function. Fine-grained access control is a very nice functionality as well. So you will have full control of which users have access to your DynamoDB tables, and inside your DynamoDB tables, you can be as fine-grained as give access to an item into one of those tables, and under what circumstances. Maybe you want to restrict access from a particular IP, an IP range. Maybe you want to give access in a time range during the day. So you have full control over that. What do we mean when we say that it's fully managed? So if you want to do this on your own, there are many things that you have to think about. And all the time that you're putting into these things that you have to set up, patching the operating system, setting up the high availability, scalability, all these things are taking time from you to put them in something else, which could be your code. With DynamoDB, you just have to focus into to fine-tune your application. That's it. We take care of everything else. We take care of scaling the infrastructure when your application demands more from us. We take care of patching the operating system that the infrastructure, the underlayer infrastructure has. We take care of everything else so you can focus on what really differentiates your business. What do we mean about low latency at scale? I mean, this is a must-have also for NoSQL database. You have to know the performance that you are going to have when you talk to the database. Here in the blue line, you can see a variation on the number of requests that a common application may have. During the days, you have more requests. In the nights, you have less requests. The green line is basically the latency you have to the DynamoDB service. As you can see, it's always below 10 milliseconds to latency to the service. And that is something that you can expect from the service. The service is built on SSD drives. It's going to deliver always single-digit milliseconds latency, no matter the scale of your application. And what do we mean around high availability? So for those of you that are not AWS customer, we basically have this concept of a region. So for example, in Europe, we have a region in Dublin. We have another region in Frankfurt. The Dublin region has 3 different, what we call availability zone. An availability zone is a cluster of data centers. So we have 3 different clusters of data centers that allows us and our customers to be very resilient applications. In DynamoDB in particular, whenever you put an item into your DynamoDB table, before you get the OK request in your request, we're going to put that item, we're going to replicate that item into multiple facilities. So it's durable by default. It's also highly available. It's designed to support 4 nines of availability. So you don't have to take care of designing this NoSQL database, this database on your own. You can use a managed service for your application. So some of the users, some of the customers that are using DynamoDB at a huge scale, I'm very sure that you're familiar with some of the customers up there. We have Duolingo. Those guys have spikes of thousands and thousands of requests per second. And in their own words, they say that without Dynamo, they wouldn't be able to scale to such number of requests. We have also Supercell, the creators of Clash of Clans, Clash Royale, Boom Beach, those very successful games. They use DynamoDB very at huge scale, and they are very happy with it. Singa, Adroll. So many customers in Spain, we have Job and Talent. Many customers using the service successfully. Very nice entry point for developers and for new users, new customers. So we have what we call free tier. It's not only for DynamoDB, but for many services that we have in the platform. And it's meant to basically give you the option to test the platform, test the services. We give you free credits, free access to resources. So for example, you have 1 million Lambda functions per month to try the services. I think that's a pretty generous tier. And of course, I mean, this is a very nice way for you to create your application, create the right business model around your business, and be sure that you're going to be able to deliver if you are successful. So you're going to have scalability built in, you're going to have high availability, backups, and everything without much effort from your side. All right, so next step for you. Go to the console. If you're an AWS customer, you just have to go to the Lambda console. If you are not an AWS customer, you have to register. Please do so. And give it a try. Give it a try to the service. Give us some feedback. You have my Twitter handle over there. If you want to contact. And if you have any questions, I'm open to questions. All right. Thank you, guys.